Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. Firdaus Kapadiya, and he will talk on soil rejuvenation using agricultural waste. I now request the speaker to begin. Thank you.
Thank you. Uh, Good evening, everyone. I'm Firdaus Kapadiya and from JCL Henry Incorporated. And under this company, we also have our JCL AgriTech, which is representing UAG bionutrients. Uh, all agriculturists face a problem of agricultural waste. Uh, Handling this waste and managing this waste is an issue which farmers are facing all over India. Um, what we bring to the table is a better way to use this waste to generate energy as well as rejuvenate the soil in your farm. So, what the way we go about this is that we first check the soil conditions of your farm and determine what nutrients are required for bringing back that soil to its original strength and fertility, and accordingly process your waste in such a manner that you produce energy as well as nutrients which can be put back into the soil to balance the fertility of the soil and rejuvenate it to its almost original condition. Uh, this technology is has been developed in Japan, but has been licensed worldwide to a company UAG, which is based in Australia, and we represent that company for the Indian and European markets. Coming back to the technology, uh, once we have the report of the soil report, testing report of the soil, we analyze that. We use that, and again we require information about the agriculture waste being produced on that farm or in and around that farm, and that will help us to design a system which, when put in place, can um, use the waste to produce energy and the nutrients required for that soil. Going to the next slide, this is a brief um, overview of the process. That any organic waste, may it be food, garden, crop, or animal waste, can be used in this facility to produce biofertilizer, clean energy, carbon credits, and captured food grade carbon dioxide. Uh, Once this uh, plant is operational, you get biofertilizers which are to be put back into the soil to rejuvenate the soil. You get clean energy which can be used for your farming operations or even for your community in and around the farm. Carbon credits, because this generates a large amount of carbon credits which are again useful economically, and captured food grade carbon dioxide which can be used for packaging of the food products of that farm or of nearby farms. So this is the brief overview. Coming to the details, this facility is basically uses organic material which is then put through anaerobic digestion to produce biomethane, which is used to which is converted into energy, and at the same time, the remaining part of the sludge from the anaerobic digester is put into something which we can call as composting pits, similar to that, but which also has vermiculture, and this gives carbon-based biohumus fertilizer. So this technology is modular and scalable to industrial size. Mainly, it's the anaerobic digestion process and the climate-controlled vermiculture. These two processes are designed by the soil test using analysis of the soil testing and the agriculture waste test, and the farmer is benefited with reduced emissions, green energy, and healthy soil for the future products. The way we work on the project is initially is engagement and feasibility, where we do a feasibility study of the farm. Under that, then it's the agreement between the farm owner or the organization and our company. Then the plant design is done, which uh, will suit that particular soil and that particular waste. Procurement of the plant equipment and machinery, construction, commissioning, all this is handled by us. And then comes the monitoring, continuous monitoring of the plant operational parameters to ensure everything is running at its best. And this is done by a remote monitoring team. They will generate operational reports and alerts periodically. So if there is something which is not working as desired, that will be known to them and they will help to troubleshoot that problem at the farm. Now, what we need in this is the project partner who is the large scale regenerative vegetable grower or processor. And it is based on vegetable processing waste. Usually the economical plant size, the industrial size, which we say would process about 7,000 tons per year. That plant costs about 90 crore rupees, considering Australian costs. In India, we are sure it would be lower, but that would be decided quite soon that how low we can go, how much we can indigenize the machinery and equipment. Now, when we come to the process, again, as I mentioned, we are talking about a 7,000 tons per year vegetable waste production. The annual capacity is designed for that. Uh, the energy generated is 12,400 megawatts during the year, out of which 11,000 is usable energy, which comes in as um, electricity and heat, and the remaining is goes towards wastage, or during the process itself it is used again. The amount of biofertilizer produced would be about 6,400 tons per year. So from 7,000 tons of waste, you get 6,400 tons of fertilizer, and 27,000 tons equivalent of carbon dioxide is reduced emission. So you get an equivalent of 27,000 carbon credits, because each carbon credit would be covering 1 ton of carbon emission saved. And considering present international values between $5 to $8 per carbon credit, let us consider the lowest $5. That would work out to about 450 rupees at current exchange rates per ton or per carbon credit. So you can generate about more than a crore of rupees by trading these carbon credits. The IRR over a period of 10 years would be 27%. Over a period of 20 years, it is 30.1%. And the employees required during construction would be about 20. But once constructed and ready, the operational employees required are just 3 for this plant. So it's not a very labor intensive plant. It is almost fully automated, and you just need to supervise that the plant is functioning properly and the parameters are as desired. Our team includes Mr. John Barraclough, who is the founder of this company, and the co-founder is Peter Pizzarelli. Both of them are based in Australia, and they have developed this technology in after taking over the license from the Japanese company and fine-tuning it. They have multiple plants running right now in Australia, and will now be looking for plants in India and other territories. So in case of India, I would be heading the company here. So that is a brief presentation of this. Again, I would like to come back to a different presentation from the same company. where we provide you another product which is again related to agriculture and the future in that case. Now, just let me share my screen with you again. Now, this is a product, it's a software as a service product, which is known as Track S. The future of agriculture as we see it, when we are exporting products or even for local consumption. So in some countries, it would come in sooner, some countries a bit later, but farm to table traceability is coming in a strong way. And now, what is being added to it is the carbon emission reporting. So, if you're exporting your agriculture products or the produce processed foods from that, then your clients or customers abroad would surely start asking for farm to table traceability as well as the carbon emission reporting for your farm. In this case, again, this technology has been developed purely within Australia, within the team of UAG, and it started with a direct need for a macadamia processing business to manage global export compliance and track products efficiently. So, we would like to empower agriculture businesses with integrated digital tools for precise product traceability and comprehensive Scope 1, 2, and 3 carbon emissions reporting, driving efficiency, compliance, and environmental stewardship. The value proposition for the farmers or the farmer producer organizations would be end-to-end transparency. You can track products from individual farm batches through processing, packaging, logistics, and delivery to market. Integrated compliance, where you can streamline regulatory and market-specific compliance reporting, reducing administrative burden and risk. So it comes in automatically. It is generated automatically when you process the documentation. Actionable carbon insights. It provides precise Scope 1, 2, and 3 carbon emissions data, enabling businesses to identify hotspots, implement reduction strategies, and meet sustainability targets. Enhance market access, because you are supporting a premium market access by providing verifiable data on product. Operational efficiency. You can optimize your supply chain operations through real-time data, reducing waste and improving decision making. Now, coming back, the problems which farmer organizations or individual farmers face currently. The agriculture sector is facing growing pressure from regulators, consumers, and supply chain partners for product governance, safety, and environmental sustainability. The key challenges are fragmented traceability, usually limited visibility beyond specific supply chain stages, making end-to-end tracking difficult. Like once the initial traceability is with the farmer who can trace it from seedling to plant harvest. Then once the product is harvested, it goes to packing houses. Again, that chain is broken, the visibility is broken. So then you need to get the data from the packing house about how it was processed and packed. Then it is handed over to the shipping company, which carries it to the port of destination and then to the final client. So various agencies are handling it in between. So this fragmented traceability becomes a problem because you cannot the end product user cannot really come back or trace it back to the correct farm. Complex compliance. The organization needs to develop reports, quality and other pesticide reports um, to meet the regulations of the country which is buying them product. Lack of Scope 1, 2, and 3 emission data. Right now, most farms do not have this traceability, so they do not generate the data for carbon emission at the farm. Inefficient data management, manual processes and disparate systems lead to inefficiency, data silos, and lack of real-time insights. So some data is stored at each stage of the process and becomes difficult to integrate all of that into one. And market access barriers, you have difficulty facing, if you face difficulty in accessing premium markets without verifiable sustainability and traceability data. The solution what we offer is this TrackS platform, which is a cloud-based modular solution addressing critical challenges, leveraging foundational expertise in not only macadamia exports but in all agriculture products. So here you have farm grade integration. So integrated tools for farmers to record planting, harvesting, inputs, energy consumption, post-harvest handling. Again, batch and lot tracking, unique identifiers to process and distribute. Yield and quality monitoring, capture yield, quality metrics and certifications, and processor to market traceability. So processing and packaging data transformation, inventory and warehouse management, logistics and distribution tracking, and export documentation automation, which generates all the permits and certificates and customs declarations required for exports. So all that is provided on a single platform to the producers or the exporter. Then again, you have carbon emission reporting, where you have automated data ingestion that connects with the existing system to collect activity data, fuel, fertilizer, electricity, transport, waste generation, emission factor database, regularly uptime database relevant to agriculture and supply chain logistics, calculation engine which automatically calculates the emission categories relevant to the agriculture value chain, dashboard and reports, real-time monitoring, hotspot identification, and compliance-ready reports are at your fingertips. Scenario modeling allows users to model impact of operational changes on carbon footprint. So if you decide to change some operational, make some operational changes in the plant and the farm or the packaging or the pack house, immediately you can model it to find out the effect on the carbon footprint and then decide to go ahead with that change. Compliance and audit trails, immutable auditable record of product movement, quality checks, and environmental data for verification. Once input, the data cannot be changed, so it is not possible to amend it later as suits you. So it is what is entered the first time is the final data. User-friendly interface with intuitive web and mobile cell phone interfaces for various user roles, so you can track it over your device. The market opportunities for farmers, growers, agriculture processors, agriculture exporters and importers, industry associations, and cooperatives. So, increasing demand for transparency, consumers and regulators demanding food origin, safety, and journey, sustainability and ESG reporting for scope 1, 2, and 3 emissions, climate change mitigation. This helps, using this would help you to decarbonize your agriculture processes. Digital transformation, adoption of digital tools for transforming traceability, including blockchain, IoT, artificial intelligence, RFID, and cloud storage. Food safety and recalls, essential for rapid response. Market access requirements, export markets demanding traceability and sustainability. Government initiatives, investment in agricultural traceability and carbon accounting. So all these drive this product. The differentiators for TrackS compared to other platforms available worldwide is it's the only holistic solution which directly integrates scope 1, 2, and 3 carbon emissions reporting into the traceability platform. So you no need for separate systems. Deep traceability with carbon. So it started with granular agriculture product traceability from farm gate, built from real-world processing experience, allowing for more precise and verifiable Scope 3 calculations, and user-centric design. It is developed from an operator's perspective over a long period of more than 11 years, prioritizing ease of use and practical functionality so that any and every farmer and every agriculture processor, food processor, or supply chain manager, exporter can handle this product. Business model right now, it is a sales model, or it is also as a software as a service. The costs have so far been just estimated, but not yet finalized. We do have tier one, which would be for farmers, tier two, which would be for growers and packers, tier three for large processors, like say tomato puree manufacturers who use multiple sources. And finally, the largest one, which is the enterprise license, which would target large farmers or farmer producer organizations or cooperatives, and they would be able to use this license, single license for all their production. So with this, I come to an end of the presentations. I would now like to check with you if you have any questions on both of these and try to answer them at the best of my ability.
Thank you very much, sir, for your talk. I will take up the questions now.
Sure.
The first question is, are there any specific crops whose waste materials is especially beneficial for soil rejuvenation?
Uh, the one which we are doing the first feasibility, which we did the first feasibility study in India was on sugarcane waste, and that makes it quite viable. The other product which we tested was waste from corn fields, maize and corn. So these two waste have been studied extensively in India, and both of these would match our requirements. But I'm sure we can use rice husk, wheat straw, and almost any sort of agriculture waste, including uh, what we call forest waste, which would be twigs and leaves of multiple plants, sweepings from the forest area or from open areas. So it can practically use almost any waste. What would differ is basically the additives, because in case that waste is not able to match the requirement of the soil in that area, then we need to add some particular waste from other sources. So, like if we find that the soil requires a particular component more than others, and sugarcane waste is producing only about 80% of the requirement, then we can suggest the other waste which will be able to manage the remaining 20%.
Okay. What are the common challenges farmers face in managing agricultural waste sustainably?
Right. Right now, currently, quite a lot of waste is either burnt off on the field. Um, Secondly, it is harvested and used as cattle feed, or try to sell it as bio waste in the form of briquettes and pellets for energy generation. But then all these are low cost options. So the farmer doesn't really earn out of this waste. And in fact, sometimes the energy spent on processing this waste is more costlier than the selling of the waste. So what this process provides us is energy, which again is either usable or saleable. So, like considering a single plant, we are talking about 12,000 megawatts during the year, which is quite a decent amount of energy. And again, the nutrients to rejuvenate the soil, because with the usage of fertilizers, the soil has been depleted of certain minerals and micronutrients. So those can be given back to the soil so that future plants can grow organically much better than they would grow with chemical fertilizers. So organic certification would be easier. The processes handled or during the organic productions, the yield comparatively is usually lower than chemical fertilized fields. So in this case, that does not occur. They can expect yields practically equivalent to the farms which are chemically fertilized.
Okay. How can we address the issue of crop residue burning, which is still widely practiced in some states?
Yes, so that does create air pollution and a host of other things, including carbon dioxide emission, which it increases your carbon dioxide emission by a huge amount. And as our country also is going towards net zero, uh, by 2070, we intend to be net zero, but by 2030, we expect to be 70% compliant with net zero. So that is made quite difficult when you burn the stubble of the crops on the field itself or even after harvesting. So that air pollution and the uh, effect on the climate would definitely improve by using this process.
Okay. Is there an economic model where farmers can benefit financially by adapting waste to soil approaches?
Uh, yes, it is highly economical and it is very feasible. The only thing is, for individual farmers, depending on the farm size, it might not be economically feasible. But if it's a cooperative of farmers or a farmer producer organization with multiple farmers on its rolls, then we find that this is a very workable model. For sugarcane waste, even at the sugar mill level, it's economically feasible because this would help them to produce CNG, which is again marketed quite conveniently. You can either sell it to the government petroleum companies, or you can, each producer of CNG gets a license to open 4 CNG pumps on highways or in any other city, and it can be sold through that. Usually, the cost for producing this bio CNG would be about 30 to 35 rupees per kg, while the selling cost to government companies is about 60 to 62 rupees per kg. And if you're marketing it directly through your pumps, it is sold at almost 92 rupees a kg. So it is very feasible economically because not only you get nutrients to rejuvenate your soil, which would be almost free of cost, considering the money economics of the fuel generated or the energy generated.
What role should government policies and subsidies play in encouraging soil rejuvenation through agricultural waste?
Um, I think the government surely believe that the government would be or should be heavily invested in this, and they should be able to provide subsidies to set up these plants, at least for farmer producer organizations, as these organizations have been cooperating with the government to increase the exports of the agriculture products, improve the food processing industry, and also increase the exports to generate foreign exchange. So I'm sure the government can find itself on a good in a good position to provide good amount of subsidy for these plants, as well as ensure that that helps them meet their carbon zero target very soon. In fact, much sooner than 2070 maybe.
Okay. What are your company's biggest success so far in turning agricultural waste into value-added products that restore soil fertility?
As I mentioned, that most of these plants initially came up in Australia, which is again a very agriculture intensive country. Of course, the cropping pattern is different because there they have a single crop over thousands of hectares of land, and the farm size again is usually 10,000 hectares plus. So that is a major difference. So there it is, individual farmers can also afford this plant. In fact, our largest customer there is a group of farms. So it's basically a single farm owner, but having farms in multiple locations. So they transport their waste from the smaller locations to this central place, and there they are processing it using this technology. And from being negative, from having a negative balance sheet or a profit and loss statement till 2022, in the last 2 years, they are now enjoying good profits. So they have been
Okay.
able to change their financial profile totally.
Okay. What are the biggest challenges you face in Maharashtra when promoting agricultural waste-based soil regeneration?
The biggest problem faced is the size of the farms and the individual farmers not being able to afford such cost to set this up. But we are discussing it with sugar cooperatives or also other farmer produce organizations which have large number of farmers with them. In Maharashtra, we have organizations which have 400 members to 4,000 members, and such organizations are already using. They do have some preliminary technology where they incinerate the waste to generate energy. In this case, there is no incineration involved. So there is no burning, there is no smoke generation, there is no carbon dioxide generation. And burning also utilizes oxygen, so it draws away oxygen from the air. And they do produce the energy part, but it's not a very feasible way of doing it. What we are trying to convince them is that although this process is a bit more costlier, but it helps to rejuvenate the soil as well as produce the same amount or in fact more amount of energy in a clean way. So what you are producing is clean energy or green energy rather than energy from waste, but creating more waste and more pollution along the way.
Okay. Can you share examples where the use of agricultural waste is in your solutions has resulted in carbon sequestration or reductions in greenhouse gas emissions?
Yes, each unit which has been set up, like the basic unit we consider, which is 7,000 tons per annum, which is quite small quantity otherwise. So that unit does produce or reduce carbon emissions equivalent to 27,000 tons of carbon. So if we are considering that even if each district has 4 to 5 of such plants, they would be reducing the carbon emissions to a huge extent, more than 1 lakh tons per district, which would surely be very helpful in achieving net zero targets sooner or later, and without spending astronomical amounts on that. Because otherwise, right now, there are other options are green hydrogen and other green energy solutions, but they do also have, because originally solar was thought to be a renewable power source which was clean energy, but now coming to an end of the cycle of the life cycle of the solar panels, we realize that India needs to handle 60 million tons of plastic waste panels every year. So we have, it's solar is no longer considered a very green technology, and green hydrogen again faces the challenge of pricing because it is too expensive compared to the regular hydrogen production. Regular hydrogen production would be sellable at about 50 rupees a kg, whereas green hydrogen is being sold at 360 per kg. So that's why the usage is not, the demand is not growing as fast as is required. But this is one technology where we feel that the demand is very easily met. You generate biomethane, which can be sold as bio CNG, or you can convert it into electricity and use that electricity or sell that electricity.
Okay. How does JCL AgriTech collaborate with local farmers, government agencies, research institutions, or NGOs to promote soil regeneration?
Right. We have entered India quite recently. It's just about beginning of this year, somewhere in March 2025, we have started approaching the Indian market. And we have been doing feasibility studies in areas which are also having tribal small agricultural areas under tribal agriculture, but which is sustainable. So the main issues they were facing were the depletion. So this helps them to rejuvenate their soil. And since they have small holdings, we have been working through NGOs which have an approach to multiple farmers or multiple tribals, at least where the main NGO we were working with has about almost can approach about 9,000 tribal farmers at any time. So they are helping them with sustainable farming and um traditional uh, cows breeding, not imported cows, but basically the traditional ones which were found in their area. So that is being done. So that NGO has been quite helpful, and we have found we hope to have very good results very soon, which can be used as an example for marketing this technology all over India or developing this on an all India basis.
Okay. Are there policy incentives at the state or central level in India that have helped or could help your work in agricultural waste management or soil health?
Right. There are policies, but we need to study more on how they would help us or help our clients to um, set up these units and improve their agricultural processes. So that is an ongoing process, and we hope that within by the end of this year we should have that policy very clear on what would be the benefits and how we can get government supporting this technology.
Okay. Do you engage in any community outreach training or demonstration farms to build awareness among farmers about
Yes,
the
we plan.
benefits and methods of soil regeneration?
Right. In fact, we are planning what once the first unit, the pilot unit is set up in India, we would be inviting farmer organizations to visit this place and also conducting community outreach in other states where we could carry videos of this unit and have presentations to local farmer bodies so that they can understand the benefits of using this system and decide to set up this system in their farms or in their communities.
Okay. Thank you very much, sir. We have now completed the round of questions on behalf of agricultureinformation.com. We like to thank Mr. Firdaus Kapadiya for the talk and for answering the questions. This meeting will now be closed.
Thank you very much.
You are most welcome, sir.